So continuing with example 1, I will leave part E up to you to do. It's a little bit mechanical. Calculate the variance of the error term as well as the standard deviation. Remember, it is SSE divided by n minus k minus 1 degrees of freedom. Take the square root. That should give you the standard deviation of the error term. More importantly, part F, it says assume that the bivariate normal probability distribution assumption holds use information in the printout to test HO, rho is equal to 0 versus HA, rho is not equal to 0 by setting alpha equal to 5%, 1%, as well as 1% of 1%. What do you conclude about how X and Y are related? Now, as I said, I'm going to do this problem a little bit differently. So although you have the printout, and I'll show you the answers on the printout, let's go ahead and do it the very long and tedious way. So step 1 is to state the hypothesis as always. So step 1. So the hypothesis is going to be H0 is going to be rho is equal to 0. And HA, the alternative rho, is not going to be equal to 0. So this is a two-tailed test. It most always will be. Step 2, we need the CV, or the critical value. This will be a t-test because we're using only 8 observations. So the critical value is going to be T alpha divided by 2, comma, n minus k minus 1 degrees of freedom. Let's go ahead and use 5% for our analysis. So 5% divided by 2. You know what? Let's be a little bit more interesting. Let's use 1%. And the degrees of freedom are going to be 6 because this is going to be 8 minus 1, which is equal to 8 minus 2, and minus 2 degrees of freedom. So we look up in our table. We would like this to be 1%. So half of it is going to be half of a percent. So we're going to look at the column right here. And we're going to look at the row 6. So the test critical value is going to be 3.707. I'm rounding right here. Hopefully nobody's confused. So this is your rejection zone. And you're ready to go. So part 3, the actual t-stat, or test statistic. Formula is relatively easy. So T star is going to be equal to R multiplied by the square root of n minus k minus 1 divided by 1 minus r squared. So I'm just going to make this a little smaller. I have the equation already worked out. You can always check my math as usual. You should get a test statistic of negative 7.36. I guess it's somewhere here. Clearly that's in the rejection zone. We reject HO. Therefore, the relationship is strong and negative.